Some basic properties of charges. First of all, we would see how the charges are added or even subtracted. You might say we are going to test the additivity of the charges. Charges are added by simple algebraic method. When we underline algebraic method, we simply mean that charges should be noted along with sign also. Just suppose there are two objects having the charges Q1 and Q2. They are having the charge plus Q1 and minus Q2. When they are brought in contact, the total charge on the system is going to be plus Q1 minus Q2. Here you see intentionally I have shown this zigzag shape. I want you to carry the message that the shape, the size, the material of the object is not material here. Only thing is that you are going to add the amount, the magnitude, the modulus of the charge you are going to add. Suppose they are the charges Q1, a very small one, and a big conductor that had the charge minus Q1. You bring them closer, it is 0. So now we can say that charges are always added by simple algebraic method. Second very important property is that of conservation of charge. Charges are conserved. That means charges can never be created or produced. When we are saying all this, we have an isolated system in our mind. Isolated system. What does it mean? That means it is not going to make any transaction with outside. A system is confined to its own boundaries. You are neither giving the charge or taking the charge from it. In that case, the total charge on this system is going to remain constant throughout. It will neither increase nor decrease. Now, suppose you are having a charged body. Even you might consider neutral body. You are not having the control on the surrounding. In its vicinity, there might be presence of some other charged conductor. Now, that is going to make some impact on this, on the internal arrangement of its charges, its particles. Its particles might be disturbed. Particles simply means electrons because protons are not movable. So, if electrons are disturbed, electrons get aside, they have concentrated in one region, then obviously there is deficiency of electron the other side. But overall, this side would obviously become positive, deficiency of electron. This side would become negative because of the excess of electrons. They have migrated. And this migration, you never know, it might happen because of the presence of some surrounding big conductor, big charged conductor. But what I mean to emphasize here is that within this conductor, the total amount of charge is not going to be disturbed. This is what exactly this principle means. You see, in the entire universe, this law is applicable. Nobody knows what type of net charge is being owned by the universe. Nobody can say whether the total universe is positive or negative. It is the result yet to be explored. But it's a pleasant matter that we know it's in our knowledge that total Earth is negative. Total Earth is having negative charge amounting to about 10 lakh Coulomb. Total Earth is negative. So, when we say that total charge cannot be created or destroyed, then simply it means that total charge on the Earth will remain what it is today, that will remain throughout, unless a huge supply of charges is made from outside. This is what exactly conservation of charge means. Then there are many processes in which a misconception arises that charge can be produced as well. For example, when we study nuclear reactions like pair production, pair annihilation, in pair production, two particle and antiparticle are produced together like electron and positron, proton and antiproton. But there also this law is applicable. The total amount what it was before the reaction that shall prevail even after the reaction. Now, you see, there is one term in mechanics, you are aware of it, density. When you say density, commonly it gives the sense of this one, ratio of mass and volume. But you have to clarify when you mean linear density, then you divide mass by the length. Similarly, here also while dealing with electricity, you come across three terms having density like linear density, surface density and volume density. You should remember them. Charge upon length, this becomes linear density. Unit Coulomb per meter. Charge upon surface area. See, it's surface area, it's not the cross-sectional area. Charge upon surface area, this is surface density of charge, sigma Coulomb upon meter square. And likewise, you have Coulomb upon charge upon volume. V stands here for volume of the conductor holding the charge. This is shown by letter rho. It will have the unit of Coulomb per meter cube. Now, in higher studies of the same chapter, we'll see that we require these while dealing with line charge, surface charge, or even the charge distribution throughout the bulk. Then we'll write the formula for potential and electric field in terms of these densities.